Hey everyone, so we are moving to the tail end of our quadratics unit. So today we're gonna focus on writing the equation of a parabola when you're given either a graph or some points. So start by sketching this parabola. So that 5 is a GCF, so I'm gonna pull it out. So negative 5 x squared minus 5x minus 6, so that is factorable. X minus 6, x plus 1. So I know my roots are 6 and negative 1. Let's see, negative b over 2a, so that's negative 25 over 2a, so negative 10. That gives me 2.5. Let's see what I get if I plug 2.5 in here. Negative 5 times 2.5 squared, 25 times 2.5, plus 30. So I get 61.25. Alright, so it's a sketch. So let's see. It's mostly like that. So I got my negative 1, I got 6. Let's call this 60. So 30's around here. The Y-intercept is 30. 2.5, 61. So we're like here, here. All right, it's just a sketch, so nothing crazy. And that's my graph. Okay. How many points are needed to define a line? So remember in Algebra 1, when you wrote the equation of a line, you needed 2 points. So you need exactly 2 points to write the equation of a line. So how many points do you think you need for a quadratic? We need 3 points for the exact. So now the difference here is we're going to do a few different things. Write an equation versus the equation. So sometimes there is more than one answer. Okay, so like look at this one. Now we're going to write the equation in standard form. All right, standard form is your ax squared plus bx plus c. And it's an equation, so y equals. So don't just write the ax squared plus bx plus c part. All right, so now there's a couple ways to do this. So either you can, I think the easier way for this one is to look at the roots. They gave me my roots as 4 and negative 2. So that means I have x minus 4 times x plus 2. You also could use the fact that that's your vertex. Y equals x minus 1 squared minus 9. But we do have to check the scale. So is our over 1 up 1 working? So if I go over 1 up 1, that seems to work. Over 2 up 4. 1, 2, 3, 4, over 3, 1, 2, 3, up 9. So this one is the normal shifting rule, over 1, up 1, and so on. So all we're going to do is multiply this out. So x squared minus 2x minus 8. And then if we did it using the vertex, this is x squared minus 2x plus 1 minus 9. So we get the same answer. So however you want to do it using either the vertex or the roots, it's up to you, whatever you want. Whatever makes more sense to you. When I'm given the roots, I like to use those. I just think multiplying that out is a little easier. All right. Now, I didn't really show work, but it's FOIL, right? X squared plus 2x minus 4x minus 8. All right, so take a look at this one. Try it on your own. Pause the video. So we don't have any roots here, right? So we can't use the roots. I have my vertex of 3, 1. And then we really need to check our shifting rule. So I have over 1 up 1 doesn't seem to work. Let's see what we have though. So it looks like 0, 7. So it's over 3 up 1, 2, 3, 4, 5, 6. Over 3, up 6. Ooh. How do we get from 9 to 6? That's a little tricky. All right, so here's what we're going to do. We're going to write it. There's supposed to be a number in front of this, right? X minus 3 squared plus 1. So we need to figure out what's that A, right? So we're going to use the fact that the y-intercept is 7. We're going to plug 0, 7 into our equation. So my y value is 7. My x value is 0. So this is negative 3 squared plus 1. I'm going to subtract 1 on both sides, and I get 6 equals A. Negative 3 squared is 9. Divide. So we get 6 over 9, which is 2 over 3. So my equation is 2/3 x minus 3 squared plus 1. And now we're going to take some time and multiply that whole thing out. So this is x squared minus 6x plus 9 times 2/3. 2/3 x squared minus 4x. Let's see, 3 plus 6, and then we have that plus 1. So my final answer is 2/3 x squared minus 4x plus 7. So I use my vertex to write in vertex form, and then I put the A in front because I had to figure it out. I plugged in 0, 7 to figure out what my A value was. All right. Again, try it on your own. This one's a little easier, actually. So my vertex for this one is negative 2, 3. It looks like I'm going over 2, down 1. Over 2, down 1. Is there another point on here? Looks like that one. Let's see, that's over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. All right, I'm not really sure what's happening, so I don't know that I can use the scale. So I'm gonna use the 0, 2 again. Same idea. I was trying to figure it out in my head, but it's not working. All right, so we got y equals a times x plus 2 squared plus 3. All right. So now my a is going to be negative, though, right? When this works out, it should be negative because it's upside down. All right, so I'm going to use the fact that my y-intercept is 0, 2. So 2 equals a times 2 squared is 4 plus 3. Subtract 3, you get negative 1 equals 4a. A is negative 1/4. That's actually what I had in my head when I was thinking over 2, down 1. This might not be an exact, I don't think that's an exact point. It's this point. It's over 6, down 9. Okay, anywho. So we get negative 1/4 x plus 2 squared plus 3. So I'm going to FOIL out x plus 2 squared. That's x squared plus 4x plus 4. Multiply through by the negative 1/4. And then combine with the 3. Don't forget your x squared. I had a student last year, or 2 years ago, he missed like 5 points because every single problem he didn't put y equals, and I will take a point off. This is an advanced class. It says write the equation. It's not saying write an expression. Okay, so that was using a graph. Now we're just going to be using some points. Right? So now it says write the equation of a quadratic function. So it doesn't have to be, it's not specific. They're only giving us 2 points. So we can pretty much, if we want to change the a up, we can. It doesn't really matter. So if those are my zeros, what would I do? So x minus 4 times x minus 3 over 2. So if we FOIL that out, x squared minus 3 over 2x minus 4x plus 12 over 2. Now you can write, because it says a equation, you can rewrite this however you want. I'm going to multiply the entire thing by 2 to get rid of the fraction. So mine is going to be 2x squared minus 3x minus 8x plus 12, 2x squared minus 11x plus 12. So that's my equation. You didn't have to do that. You could leave it with the fractions and make that negative 11 over 2 plus 6, but I wanted to get rid of the fraction. So. Okay, so now it says the equation. So now there's no guesswork here. We have to do all the things. Now this is the hard one, okay? So let's look at what we have here. We have a point 1, 5, 0, 1, and 2, 3. Now one of these points is the easy point. What's the easy point? 0, 1. What is that? That's our y-intercept. Remember, if you plug this into y equals ax squared plus bx plus c, that 1 is which value? That's our c value. So we have y equals ax squared plus bx plus 1. So now we're going to plug in 1, 5 and see what happens. So remember, our x value is 1, our y value is 5. So 5 equals, before I was going to replace my c with 1. All right, so we're plugging in 1, so a plus b plus 1. If I subtract 1 on both sides, I get 4. All right, so that's an equation. Now we're going to do the exact same thing we just did, but with 2, 3. So my y value is 3. I'm going to use a different color to help. All right, so 3 equals a times 2 squared plus b times 2 plus 1. I'm going to bring the 1 to the other side, so 2 equals 4a plus 2b. What do we have here? We have a system of equations, and this is why we reviewed this in the beginning of the year. All right, I'm going to take the blue, and I'm going to divide the whole thing by 2. 1 equals 2a plus b. Now, why did I do that? If we put these underneath each other, what can we do? If we change the sign, I'm going to subtract. My b's cancel out, and I get negative a equals 3. So my a value is negative 3. If a is negative 3, what's b? Well, I have this equation right here. 4 equals a plus b. 4 equals negative 3 plus b. B is 7. So now I have all my values. So my equation is, my a is negative 3. X squared, my b is 7, and my c is 1. Okay. So that is why we learned system of equations earlier this year. All right, so here's another one just like the last one. I want you to try this one on your own. All right, so again, we have our 0, 3. So that is y equals ax squared plus bx plus 3. That is our y-intercept, so that's our c value. So now I'm going to plug in 1, negative 4, so negative 4 equals a plus b plus 3. When you plug in x, the x's just disappear, and you're left with your a and your b. So a plus b is negative 7. And then I'm going to plug in 2, negative 9, so negative 9 equals 2 squared is 4. 2b plus 3. Negative 12 equals 4a plus 2b. I'm going to solve this system. You can do substitution. I'm going to do elimination. I think it's easier because if I divide by 2, I get negative 6 equals 2a plus b. And then I'm going to subtract. So I'm going to change the sign at the top, actually. I'm going to make that plus minus minus, and now the b's go away, and we're left with 1 equals a. So if a equals 1, then b is going to be negative 8, right? Because it was negative 7 equals 1 plus b. So b is negative 8. Yep. All right, so that means my equation is y equals, a is 1, so just x squared, b minus 8x plus 3. And that is your answer. All right, so now here's the hard one. So this time you're not given the y-intercept. So we're going to do 3 equations and 3 unknowns. So the process is not totally different. It's harder though. It is harder. All right, so I'm going to start with black. So I'm going to start with my negative 4, 3. So 3 equals a times negative 4 squared plus b times negative 4 plus c. If I rewrite that, I get 3 equals 16a minus 4b plus c. Next one, I'll do that one in red. Negative 6 equals a minus b plus c. So that one's, can't really do anything there. A minus b plus c. And now blue, 10 equals 9a plus 3b plus c. All right, so now here's what we're going to do. We have a system of equations. It's a system of equations, 3 variables, 3 unknowns. So I don't expect any of you to have done this. So here's what we're going to do. We're going to work on these 2 first. We're going to work on our red and our black, and then we're going to work on our red and our blue. All right. So I'm going to start with the two black ones. So if I'm going to erase actually, because I'm going to run out of space. I'm going to erase this. Okay. So I'm going to rewrite the black one. So I have 3 equals 16a minus 4b plus c. I'm going to get rid, and then under it, the red equals a minus b plus c. I'm going to get rid of my c value. So to do that, I'm going to change the sign at the bottom. So those go away, and I'm left with 9 equals 15a minus 3b, right? So that was the yellow, all right? So I just did the yellow part. So I'm going to circle that in yellow. I'm going to do what I just did, but with the red and the blue. So now I'm going to do red and blue. So my negative 6 equals a minus b plus c, and my blue, 10 equals 9a plus 3b plus c. And again, my goal, I'm going to get rid of c. So I'm getting rid of c because that'll take both of these equations down to 2 variables. All right, so again, I'm going to change the sign, subtract. You can do whichever method you want. I'm going to just do the bottom. So again, my c cancels, and I'm left with negative 16 equals negative 8a minus 4b. So now I have the yellow and the green that I just circled. Those 2 only have a's and b's in them. So I'm going to work with those to solve for a and b. So if you notice with this one, I can divide everything by 3. So I'm going to do that. Divide by 3. So 3 equals 5a minus b. And with the green one, I'm going to divide everything by 4. So if I divide by, I'm going to divide by negative 4. Because that gives me 4 equals 2a plus b. Now if I put those together, that gives me 7 equals 7a. My b's cancel. So I just figured out that a equals 1. I'm going to write that up top. A equals 1. Now I'm going to go back to one of these 2 equations. I'm going to do blue because it looks easier. 3 equals 5 minus b. So that means b is 2. All right, so I got b is 2. Now I'm going to go back to one of my original equations. It doesn't matter which one. I'm going to pick the red one, this one right here, because it looks the easiest. So -6 equals a is 1, b is 2, plus c. So I get -1 plus c, so c is -5. So now I have all my numbers, so I can write x squared, y equals x squared plus 2x minus 5. This problem's a beast. I do recognize that. All right, it's the same exact thing. Try this one on your own. Remember, start by getting rid of a c. All right, so let's do blue. So 3 equals a plus b plus c. Do this one. I'm just plugging into ax squared plus bx plus c. Remember, that's what we're plugging into because that's our formula. All right, -1 equals 4a plus 2b plus c. And we can just use those two. Actually, let's do this first. Let's get rid of our c right now. So change the sign. So I get 4 equals -3a minus b. So that was blue and red. So now I'm going to do red and black. So I'm going to rewrite my red. -1 equals 4a plus 2b plus c. And now I'm going to do the black one. 1 equals 4 squared is 16 plus 4b plus c. Again, we're going to change the sign and combine those together to get rid of my c. -2 equals -12a minus 2b. I can simplify that. I'm going to divide by -2. And I get 1 equals 6a plus b. Now I'm going to take those two and put them together. So I've got 4 equals -3a minus b. 1 equals 6a plus b. My b's just cancel. 3a equals 5. Oh no, it's a decimal? Really? I can't believe I made a decimal answer. Did I make a mistake? I don't know. I don't see any mistakes. I'm going to write this on the side. So a is 5/3. Ugh. All right. So 1 equals 6 times 5/3 plus b. Okay, so b ends up being a nice number. 1 equals 10 plus b. So b is -9. And then I have to figure out my c value. So let's go right here. -1 equals 4 times 5/3 plus 2 times -9 plus c. I'm plugging into that top, the red equation. Let's see, that's 18. So 20/3 minus 18 plus c equals -1. So let's see, we got 17 minus 20/3. 17 equals c. 17 times 3 is 51 minus 20, 31/3. Ugh, that's terrible. I hope I made a mistake. If you guys caught my mistake, good for you, because that's terrible. All right. Y equals 5/3 squared minus 9x plus 31/3. And that's our answer. All right, homework. This is a beast of a lesson. I do understand that. This is hard. But sorry. Welcome to Advanced Algebra 2.